Hey hackers, Blue Cosmo from CCS here, and welcome to Module 3 of the Introduction to Cryptography course. Today we are covering asymmetric encryption, so let's just jump into it, right? So in asymmetric encryption, this looks pretty similar to how symmetric encryption worked, right? But the most notable difference is the different keys, right? Because in symmetric encryption, it took plain text, then took an encryption key, and use that key to encrypt it and make it ciphertext, right? And in symmetric encryption, it would use the same key that it used to encrypt to decrypt and bring it back into plain text. But, the thing with asymmetric encryption is that it has a separate decryption key from its encryption key. These are two different keys. One key is used to encrypt, and one key can be used to decrypt. So that's how the cipher works, and it makes it a little bit more secure, right? And in fact, asymmetric encryption is more secure than symmetric encryption, right? Yeah. Again, this image is on the GitHub repository. I did draw it myself. But regardless, let's actually go in and take some notes, because this section is a little bit more lecture-based rather than the more interactive ones we've had. So I guess we can jump into it. Here. Asymmetric encryption. So what is asymmetric encryption? It is a ciphering algorithm that uses a key for encryption, and this key for encryption is called the public key, and a key for decryption, and this key for decryption is called the private key. Now, asymmetric encryption is often referred to as public key encryption, but yeah, just to let you guys know. It is more secure than symmetric encryption, as I mentioned before, and we did cover symmetric encryption in the previous module. Private keys, so the private key, right, is only available to the owner, while the public keys are publicly available, right? Now, they're not necessarily publicly available, but it's available for whoever the owner shares it with, right? The asymmetric encryption does allow not for only encryption, but it also allows for authentication. Now, we're not going to dive too much into this, but it's just good to know that asymmetric encryption allows for authentication because the cipher's public key can assure that a user with the private key sent the encrypted message. All right. So it basically allows you to ensure that it's the message you're getting or the ciphertext you're getting is coming from the right person, like you. So now we're going to talk about the Diffie Hellman key exchange. Now, this was created by a Dr. Whitfield Diffie and another doctor, and this doctor's name was Martin Hellman, hence Diffie Hellman, right? Now, it basically allows for the generation of, or I guess the generation and exchange of asymmetric keys. because we need two keys, right? We need one for the public key, one as the private key. So we need to create these two keys, all right? Now, to save myself on time, I'm going to show you guys the course overview. And I'm going to kind of step by step. Now, don't go ahead of me because I want to kind of walk it through you guys, right? We have two users, John and Jane. They will both pick two whole numbers, all right? Now, both numbers must be larger than 1, all right? Jane's number must be larger than John's, okay? Now, keep in mind, these numbers that they're going to pick are going to be very large, not even double digits, not even triple digits, probably. Like, they're going to be very large whole numbers, because the larger the number, the more secure this process is going to be. However, it's going to use more processing memory, all right? Now, we can see here that we have the number 1, then we have John's integer. Now, John's integer, again, has to be greater than 1, so that's fine. But Jane's whole number, or Jane's integer, will have to be bigger than John's, okay? Now, you can hear a siren in the back, I'm sorry. Now that John and Jane have their whole numbers, they're going to both pick two random numbers and run it through the following equation, okay? Now, just to keep in mind when we're looking through this equation here, that the double asterisk represents the power of, and we already covered the modulus represents the remainder of, right? So John's result is going to be equal to the integer that John chose up here to the power of John's random number that we chose in this scenario right here, all right? Then we're going to take that value and divide it by Jane's integer that we have up here, and the remainder of that equation will be John's result, okay? Now we're going to do the same thing with Jane. So we're going to take John's number and take it to the power of Jane's random number. All right, so Jane chose a random number right here. And then to whatever that values to, they're going to divide it by Jane's integer that she chose up here. And whatever the remainder of that equation is going to be Jane's result. Cool. So now, I'll zoom in a little bit more so you guys can see that. So now we can see that John and Jane had to send their respective results to each other, all right? These results will generate their keys, okay? So now we can actually generate their keys. So John's key is going to be equal to Jane's result, which is right here, which is basically the remainder of this equation, divided by her number. So, John's key is Jane's result that we got from right here, and it's going to go to the power of John's random number, because they picked two random numbers right here. And then they're going to divide it by, or find the remainder of that with Jane's integer that we chose from up here, okay? Now Jane's key is going to equal John's result to the power of Jane's random number, where we chose two random numbers. And that random number is going to be divided by Jane's integer, which is right here. And we're going to divide that and get the remainder of that. Now, if you wanted to, you could easily program something like this on Python. It's literally just math, right? You just get the input for all these numbers. You can even use the random module to create random numbers so they don't even know what it is. Could be make it more secure, who knows? But you could easily create a Diffie Hellman key exchange, all right? So I just want to bring that kind of concept to your minds, right? Because that's kind of how the Diffie Hellman process works, all right? And that's it. That's all we're covering, all right? Asymmetric key encryption can be very complicated, and it can get, the more we dive into it, the more complicated it's going to get, right? Now, this is an introductory level course, so you guys need to understand these set fundamentals before we can make a more advanced course where we're going to go into all these advanced concepts, and it's very easy to get lost, right? This already is a hard enough course for people who are new to the cybersecurity world and things like that. So that's all we're going to dive into as of right now. All right. Now, there is no homework for today's module, so you guys can easily go to the next module where we will be covering other ciphers and types of encryption, right? We're going to dive into the Visionaire cipher and base 64, really. All right. So I'll see you guys over there in the next module. So make sure to leave a like here, subscribe, and do that whole YouTube algorithm thing. And I'll see you guys in the next one. Before I say goodbye, make sure if you're on the website to go ahead and try to quiz yourself, because you can take this course on my website. All right. But anyways, stay happy, stay positive, and as always, happy hacking.